Now we are in lesson 5.2. It's about descriptive statistics. So let's start. First, we're talking about the measures of the central tendency. And this part we something called about the arithmetic mean. Also, we say about we say in another way the average. The notation it's x bar. When I say sigma fi xi over n, it means I will multiply the value by its frequency. I will add it all over the total, and it means the total number. So let's say, for example, I have the grades. I have, for example, grades 12, 13, 14. And I have two students that got 12, three students that got 13, four students that got 14. So I will do it's 2 times 12 plus 3 times 13 plus 4 times 14 over the total. It means 4 plus 3 plus 2. So over 9, and then we find the average. And sometimes we don't see the fi, the frequency, because they write the sum of xi over n. It means I write 12 plus 12 plus 13 plus 13 plus 13 plus 14, 4 times I added. So, and I prefer to multiply it like this. If I'm using all the population, we will write the mean as mu. We write this notation. Now, if the data is an interval, we take the center to multiply it with the frequency. For example, I have the interval between 5 and 10. So I take the center. How do we find the center? We make 10 plus 5 over 2. So it's 7.5. And then we multiply it times the frequency. And then we add all the values over the total to get the average. What does it mean mode? Mode, it's the value that has the highest frequency. The median is the value in the middle. And in this case, I have two cases. If the n is odd or n is even, it means if the total number is odd, it's easy. The median gonna be the term that is n plus 1 over 2. And if n is even, the median will be the average of the n over 2 and the n over 2 plus 1 terms. What does it mean? I'll give you an example. Let's say I have those, for example, 5 terms. What's gonna be the median of those 5? Since this is odd, 5, so the median will be the number of rank 5 plus 1 over 2. It means the number of rank 3. So I will count 1, 2, 3. So it means 14 is in the middle. Look at it. There is 2 values before 14 and 2 values after 14. Now, if I have it like this, here it's even. So what's gonna be the median? The median gonna be the average of the n over 2 terms. It's 6, isn't it? It means it's the average of the third and the fourth term. This is the third and the fourth term. I'll take the average of those two, 14 plus 15 over 2. So it means the median of the series is 14.5. Now, measures of dispersion. What does it mean? We describe what is happening to the spread of the data set. So to be able to describe it, we have some points to follow. First of all, we need to find the range. What does it mean, the range? We take the maximum value minus the minimum value. Then we find the quartile. What are the quartile? We have 3 quartiles. We have Q1 called the first quartile. And how do we find the first quartile? It's the term of rank n plus 1 over 4. And we also call it the lower quartile. And this one has 25% of the data below it. Guys, we're going to do an example. Don't worry about the quartile. The second quartile, it means it's the median, so has 50% of the data below it. And the third quartile, Q3, we also call it the upper quartile, and we have 75% of the data below it. And how do we find the third quartile? It's 3 times n plus 1 over 4. It means it's the term of the rank 3 times n plus 1 over 4. And there is something called interquartile, and the abbreviation is IQR. It's Q3 minus Q1. All those values we needed to study data, to study if the data is well organized, if there is any outliers. So we need those informations. We will say, don't worry, guys, in an example. So don't worry. For example, if I said I have this data, and I want to find the median, the first quartile, and the third quartile. First, I have 1, 2, 3, 4, 5, 7, so it's odd. It means the median gonna be the fourth term, because it's 7 plus 1, 8 over 2, so 1, 2, 3, 4, so this is the median. So this is the median, this is the second quartile. I have 50% below it, I have 50% above it. Now, what's gonna be the Q1? And the formula we said it's n plus 1 over 4. It means it's 8 over 4, 2. It means the second term gonna be the first quartile. So that's it. So this is my first quartile. I have, look, 25% of the data below it and the remaining are above it. Q3, it's 3 times n plus 1 over 4. It means 6. The sixth term gonna be the third quartile. So 1, 2, 3, 4, 5. So that's it. I have 75% of the data below it. So those three values are very important later on. I want to draw the box whisker. So it's very important to be able to know how to find those values. We have something also called standard deviation, and it's very important also. And why do we use it? The standard deviation gives the mean average of the distance between each data point and the mean. So I have two formulas for standard deviation. Normally it's given in the formula booklet. So, and sometimes you don't see the FI because they count each one by itself. They add the same number twice or three times. And the variance, it's standard deviation squared. If the standard deviation is small, it means the data set close are together, and if the data if the standard deviation is large, it means the data set are spread out. Okay, so let's do this example now about the frequency distribution. So I have the grades of a class. This is the frequency. It means how many students got 12, 13, 14, 20. So I'm studying the total is 24. When I say relative frequency, I will take the frequency over the total. It's 4 over 24, 5 over 24, 7 over 24. And why do we use the relative frequency? It's very important to know that. We use the relative frequency to compare two samples from different population. For example, I want to compare the height of the man and woman in the same population and the same. So I need to use the relative frequency. It will be more accurate. What is increasing cumulative frequency? Sometimes you don't see the word increasing, you just see cumulative frequency. You take the first frequency, it's 4, then you add it with 5, 4 plus 5, 9, 9 plus 7, 16, 16 plus 8, 24. The last one should be the total. And this relative frequency will help you to find the percentage of each frequency. So I'll multiply it by 100, I will get the percentage, and my total should be 100. What I'm talking about now, all this you will see it in the next lesson in 5.3. So don't be scared, guys. You will get it later on, especially the quartiles. Now, to represent the data, every time when I present data, I need to draw it, to graph it. So we call it histogram of the discrete data. So I have a table, I have the frequency in it, I have the relative frequency, then I find the quartile, the median, the mode, the average, everything. Now I want to represent this data, so I will draw a histogram. So to examine a histogram, you need to include four keys. We say SOS, the center, the spread, the outlier, and the um, shapes, okay? So first, the center, it means you need to find the mean, mode, and median. Already you know what this means: mean, average, mode, the highest, that has the highest frequency, and the median is in the middle. The spread out, we need to find the range. It means maximum minus minimum, the maximum and the minimum. And the outliers, how do you find the outliers? Also, we need to know the quartile. So outliers, it means there is a data out of the place. There is something wrong with it. Also, we're going to do an example in the next video. You will understand how to find the outliers. If I have the third quartile Q3, I can just jump above Q3 by 1.5 times the interquartile. Okay, and if for the values below Q1, I can jump below Q1 just by 1.5 times the interquartile. For example, if let's say Q3 is 15, okay, and I got 1.5 times the interquartile. Interquartile, it's Q3 minus Q1. It was, so for example, this one gives me 2. So 15 plus 2, 17. It means I can just have the maximum value 17. All the values higher than 17 are outliers. And let's say Q1 is 10, for example, and I got the answer of 1.5 times IQR is 2. 7 minus 2 is 5. It means any value less than 5 is also an outlier. We'll see it in the next video in the example. What are the shapes of histogram? I have unimodel. If you see it, I increase and decrease. I just have one head. It's uni, yani 1. Bimodal, I have two hats. Look, I have one and two hats. Multi-model, I have many models. If you see, I have many hats. And skewed or not symmetrical, it's either it's decreasing like this, or also it could be increasing, increasing, increasing. That is in this video. In the next video, we're gonna have more example about the interquartile and all those things. And see you guys in the next video.